As we proceed on to 7.4, we're going to study the different properties of logarithms. You are going to learn how to today, you will learn how to expand a logarithm that has more than one thing in it, and you will also learn how to do the opposite. You will learn how to make it a single. So I'll write and make a single. That is the whole point of today's lesson, to be able to do those two things. So I've been trying to stress this all along. Logarithms and exponents have like corresponding properties. Now, why would that be? Because logarithms are exponents. So if logarithms are exponents, they better have the exact same property as them. All right, so let's talk about some properties that you know. The product property means that if you have two things being multiplied inside a single logarithm, that if you want to write those as two separate logs with the same base, you will have to add them. So multiplication becomes addition. If you have two things inside your logarithm that's being divided, when you separate them as two separate logarithms, you will change it to subtraction. And inside your logarithm, if you have something being raised to a certain power, that power is just going to come down in front and become a multiplication problem. Now, that might not make a lot of sense, and please know those three words. You will have to know those three products for the quiz and the test, or the test, excuse me. So this is kind of it in a nutshell. If it's being multiplied in a single logarithm, when you expand it to multiple logarithms, you need to expand it by using addition. If you see a power inside your logarithm, you will expand it by changing it to multiplication in the front. If you see something's being divided, you will change it to a subtraction problem of multiple logarithms. Let's go into it and just see how you do. I have lots of examples, and I'm going to try to, hopefully you're listening to the notes and not just watching. Otherwise, it's really going to be very confusing. Okay. We're going to take this example and change it into we're going to start by making things into a single logarithm. So, right now I have two logarithms. Here is my single logarithm. It has a little itty base of 4, so give it a base of 4. So these two are going to join together. Do you see the subtraction sign? Subtraction becomes, I'm going to show you how you can use this chart. Subtraction as expanded becomes dividing when you make it a single. So I'm going to take 32 divided by 2. Now since we can do that, we may as well continue. That's log of 4 of 16 because I divide. Now remember that logarithms are exponents. This actually has a final answer of 2. The reason being is because 4 to the second power is 16. 4 to the second power is 16. So this one actually had a final answer of 2. If you get this far, that's great. If you get this answer, that's the real answer. Okay, part B. I'm going to try to do it all at one time for you. Because we have x's and y's, we won't have just like a number answer at the end. So please write your one log with a base of 2 since they both had a base of 2. Next, you see this 6? It's being multiplied, so it's going to become an exponent to your x. Do you see that 5? It's going to become an exponent to your y. And you see this plus sign? That means I'm going to multiply, because plus means multiply, by y to the 5th. And that's all I can do in that problem because there's x's and y's. If you want to put it in parentheses to indicate that, you're more than welcome. Okay, let's try again. So I have this log with a little 3 when I make it a single log. Addition means I'm going to change it to multiplication. So in my calculator, I'm going to do 9 times 24. So I get 216. So that's a log of a 3 to 216. There probably is a power that you can do. 3 raised to some power gives you 216, but for right now, let's move on to number 2. Number 2 is kind of goofy. I think they want you to take this 3 and kind of go in reverse order and put that 3 out in front like this. And then they want you to know that log 4 of 16 is really just 2. So all of this becomes 2 because 4 squared is 16. So we have a 3 times a 2, which makes a 6. That one's kind of an odd problem. Let's just move on to number 3. So here's my single log of a 2 with a little itty bitty 2. Subtraction means division. So there's my divide by bar. And 7 is first and 9 goes behind it. So subtraction means division. Number 4, let's take this little 5. Let's do like we did number 2. Put it out in front. So we have 5 times a log with a little 3 of 8. There is no 3 to no power. That doesn't give you an 8, so we can leave it alone like this. Let's go to number 5. Again, this is kind of a weird problem, but number 5 is something you're going to see in your homework. Here's your single log with a little itty bitty 4 with a base of 4. Subtraction means division. X is first, so X goes on top. Y is second, so Y goes on bottom. Number 6, and that's as much as we can do. Here's my log. It has a hidden base of 10. If you want to write it on there, you can. You don't need to write it on there. Remember, if it's not written, it's a 10. I see an addition sign, which means I'm going to multiply. So I know that 5 times 7, if I want to put this logarithm together, it's a 35. And there is 10 raised to something. There's no power to raise 10 to get to 35, at least not a clean answer, so we'll leave it alone. Okay, here's my log with a little 4. I'm going to put these two together. Do you see the plus sign? That means you're going to multiply these two things. So 5 times 3 is 15. X times x is x squared. So addition changed to multiplication. Part B. I am going to put this 2 on that 6. So I'm going to put a little squared on there. And I know subtraction means division. So here's my log with a little 4. Here's my divide by bar. On the first thing I have is 6 squared. The second thing I have is that 9. Well, we know that that could be 36 over 9 because 6 squared is 36. We also know that 36 divided by 9 is 4. And now this is actually a pretty answer. We could do this. 4 raised to what power is 4? 4 raised to the first power is 4. So if you want to write that down, if you're struggling like that, right? Because 4 to the first equals 4. Let me scoot that up. So the answer to this one is actually just a 1. The one in your homeworks and on your tests are going to be more like this one up here. Okay? Now let's take a single log and spread it out. So if you look at A, I see 4 different things inside my logarithm. I see a 4, I see an x, and I see a y. That's going to be 3 different logs. So log, log, and log. 3 different logs because I'm separating the 4 from the x and the y. Now the 4 is first, the x is second, the y is last. Because the x is on top being multiplied, I will add those two together. That would give me 4x. Because the y is on the bottom being divided, that would be a minus sign. Let's try the same thing with part B. I see an x and I see a 729. And I see a divide by bar. This is going to be a subtraction problem because I have a division. So I'll write my log with a little 9 and my log with a little 9. X is on the top, so it will go first. 729 is on the bottom, we'll write it second. Division is subtraction. That's a very funny subtraction sign. There you go. Division is subtraction. But you see this little 4 here? He needs to come down and go in front of the log for the x because he was an exponent on the x. Now, this one can be evaluated, okay? So I can change this to 4, I guess I shouldn't have written so big, log 9 of x minus 9 to what power is 729? Well, let me show you. 9 to the third power is 729. So this is literally, that entire circle turns into a 3. All right? Because 9 to the third power is 729. A little quirk that happens sometimes. Okay, let's try this one, part A. So I see the 250 and I see the 37. So that tells me there are going to be 2 logarithms with a base of 3. 250 is on the top, put it first. 37 is second, put it last. It's a dividing problem. Dividing means subtracting. And that's as far as I can go because 3 raised to a certain power is not 250 and 3 raised to a certain power is not 37. Okay, in the second one here, I see a 9 and an x. So I see I'm going to need a logarithm with a base of 3 for my 9. And I'm going to need a logarithm with a base of 3 for my x. They were being multiplied together, so I changed that to addition. This exponent of 5 was only for the x, so it goes in front of x's logarithm. Now, this is kind of a trick. We've seen it happen a few times. Log 3 of 9 is actually a 2 because 3 squared is 9. And this one has variables in it, so it just travels down. Let's try number 7. So I hope that you see we're going to need a log for the 27. And we're going to need a log for the x. They are being multiplied together, which means this is going to be a plus sign. Oh, I missed my little 3 on this one. Put him in if you didn't. 3 raised to what power is 27? I think that one has an answer because 3 raised to the third power is 27. So this logarithm becomes a 3, and this logarithm has variables, so it stays. Number 8, I see division. I see 2 things, so I'm going to write 2 logs with a hidden base of 10. I need a log for the 3 and a log for the 7. They were being divided, so I need a subtraction sign. There's no fancy anything that happens on that. Number 9, I see I'm going to need a log for the y and a log for the z. They have a little base of 4, so make sure you get that in there. Okay, so here's the one for the y, here's the one for the z. Because they were being multiplied up here, they're going to be adding down here. Multiplication means addition. Do you see that little 2 right here? He's going to plop out in front of the one with the y, because it was y squared. And do you see that little 3 for the z? He's going to plop out right here because he was attached to the z. So this was z cubed. That's why that little 3 is out there. There's nothing more that can be done because that's all variables. Number 10, I see I'm going to need a log for the 3 and a log for the x. So here's my log with a base 5. Here's my log with a base 5. This one gets a 3. This one gets an x. Because this was division, this is going to be subtraction. This little itty bitty 2 up there is an exponent for the 3. And we know that exponents go down in front. So it goes right there. There is no fancy exponent like 5 raised to any power is 3. So this is done. I can't do any more with it. Number 11. I see I'm going to need a log for the 15, for the x, and for the y. So I'm going to need 3 logs. So they each have a base of 3 as indicated. This one has a 15. This one gets the x. This one gets the y. So you're separating them out. You're expanding them. It was all multiplication up here. I hope you see there's all multiplication, which means these are all addition. I have no outside exponents to take care of, so this problem is done. And it's probably good to note that 3 raised to no power is 15, so I am done. Number 12, I'm going to need a log for the 8, the x, and the z. So I'll write this one, I'll write it down here because it's a little, I need to spread it out. So here's my log with a hidden base of 10, log hidden base of 10, log hidden base of 10. So the 8 goes in the first one, the x goes in the second one, the z goes in the last one. They're all multiplication up here, which means they're all going to be addition down here. This little 4 is for the z only. So I'm going to put him right there because he only belonged to the z. And there's no fancy things that can get done. Okay, I hope that I explained, and maybe what you could do if you're struggling with this, take a look and see if you can go backwards, like cover this up and see if you can take these 3 things and make sense to make it a single log. Take these 3 things and make sense to get that back to there. So you need to be able to go from expanded to single and single to expanded pretty well because you're going to do it a whole bunch in your homework. Maybe let's note something, please. If you have log with a square root of x, y, let's make sure you remember something here. I need a log for the x, and I need a log for the y. I'm doing this because it's in your homework. Oh, log y. So please write this down since it will be in your homework. So here's my log for the x, here's my log for the y. They were being multiplied, so I add. Okay, I hope you remember that a square root is simply a power of 1/2. Let's write that down. Square root is a power of 1/2, and that comes from your chapter 6 skills. So since a square root is a power of 1/2, each of these belongs inside a square root, so each of those gets the 1/2. If I were to go even further and divide this whole thing by z, I would need to add a minus log z in the back. But because the z was not in the square root, I would not give it a power of 1/2. If you need to re-listen to that example, please do, because these are the kind your homework are going to look like. Your notes, as they follow, will look a little different than my old notes in the video because this is a new video. Be patient, follow along, and please make sure that you're wearing a pair of headphones.